Good evening, everyone. We are back with another Algebra 1 lesson. Today we're going to go to chapter 5.2 and we're going to learn how to solve a system of linear equations by substitution. Now, the previous vocabulary words that we learned was a system of linear equation and what it looks like. So a system of linear equations, if I can remind you, is a linear equation with variables that use the same exact ones for the second linear equation, right? So an example that you see of a system here is, here we have a linear equation, right? And the variables that they use is y and x. And here we have a second equation. Notice how they're labeled first equation, second equation. This second equation also uses the same letters y and x. Now the order does not have to be the same. Now the only thing that matters is, remember, if you have an r here, x here, then you also have to have an r here, right? So they have to be the same variables. So that is what a system of linear equations is. Now the solution for the system of linear equations, remember, that came in the form of an ordered pair, right? So first you solve for x, then you were able to solve for y, and eventually you got an ordered pair that looks like this, right? Where x is the first value and y is the second value. So looking ahead, that is exactly what we're going to be doing. But now, how to solve a system of linear equations by the book. Just keep in mind what you're going to learn today is how to solve system of linear equations using substitution. Use system of linear equations to solve real life problems. It's going to be in the later videos. So the very first thing I want you to do is I want you to write down the core concept. It's the three-step process for how to solve a system of linear equations by substitution. Step one is to solve one of the equations for one of the variables. So what does that mean? So you have one of the equations here, you have another equations here. So you choose whichever one you want to work with, right? So say you want to choose this one. If you choose this one, you notice that it's already in one variable, right? It's already been solved for one variable. What does it mean to be solved? It means saying that y equals and then something, right? So if we wanted to solve for x, here we want to get x by itself, and the last line here would say x equals something, right? So that's what it means when it says solve one of the equations for one of the variables. Now in step 2 it says substitute the expression from step 1 into the other equation and solve for the other variable. So basically here this y, since we know what y equals, which is the following, right? What we're going to do is we're going to take this y, watch my cursor, we're going to take this y and we're going to substitute that y into this second equation, right? So instead of there being a y, we're going to write all of this. Now be very careful with how you do this, because I do want you to always set your parentheses. See, you can see the example about when they substituted. Now just keep in mind step 3 before we continue with the solution. Step 3 says substitute the value from step 2 into one of the original equations and solve. So once you solve for one of the variables, right? So if you're substituting y, then you no longer have y, you're going to eventually solve for x. So here's the solution. Step 1, equation 1 is already solved for y, like we mentioned before, y equals blah blah blah, right? Whatever this is. Step 2, substitute negative 2x minus minus 9, which is what y is equal to, for y in equation 2 and solve for x. So notice we're using the second equation. And we're going to use the second equation. Instead of writing the y here, now we're going to write what y equals. And so remember to always put parentheses. We start to distribute. Negative 5 times negative 2 becomes positive 10x, right? Negative 5 times negative 9, negative times a negative, becomes a positive 45, right? Equals 19. And what we do next, we combine like terms that are on the same side, right? So 6x and 10x, we can combine them to make 16x. We are not going to combine 10x and 45 because, well, first of all, there's a variable attached to this term, right? And there's no variable here. So now we're also going to combine like terms, but notice how they are on different sides. Look at this. Look at the way they format it. All the equal signs are always right above each other because we have the left side of the equal sign, we have the right side of the equal sign. So how do we move 45 to the other side. So we subtract 45 because we do the opposite. So if here we're adding 45 to get rid of it, to move it to the other side, we have to subtract 45 to both sides. And negative 19 minus 45 does in fact give you negative 64. Now you're finally left with this last line, this last equation, which is 16x is equal to negative 64. And then you, in order to solve for x, right, because here we're multiplying 16 times x, the opposite of multiplying is dividing, so I'm going to divide 16 to both sides. So if I divide 16, this cancels out, I'm left with just x. If I divide 16 here, I'm dividing negative times a positive. Well, we only have one negative, so it stays negative, and we get negative 4, right? Notice how they say the exact same thing, divide each side by 16. Now that you have one of the equations, what you can do, honestly, you can plug, sorry, not equations. Once you have one of the variables, what you can do is you can plug this variable into either one of the equations of your choosing. Now, if you plug it in here, you still have to do some extra work, right? But the reason why they chose equation 1 is because it's already easy. It's like it's already solved for y. So if you plug in the x value that you got, which is negative 4, into here, you're going to do just straight out math, and you're going to solve for y. For example, say substitute 3, exactly what we're, substitute 3, step 3 actually. Substitute negative 4 for x in equation 1 and solve for y. So the x value that we got negative 4. So instead of there being an x, we're going to put negative 4. Now we're doing flat out, straight out PEMDAS, right? So PEMDAS says that multiplication comes before subtraction. So here this parentheses does imply multiplication. Negative 2 times negative 4. Negative times negative equals a positive, so we get positive 8. 8 minus 9, we get negative 1. So we get that y equals negative 1. Now we have our two variables, so we get our solution to be negative 4 comma negative 1. Now what I want you to do for homework is I want you to solve a system of linear equations by substitution. Now let's take a look at this first example. Right, so here you were told to solve for one of the variables, and they're both already solved for y. So technically what I can do here, since this says y equals negative 4x, I can literally replace this y with negative 4x, right? Because I'm plugging in this one in here, and I get negative 4x equals 3x plus 14, and then I get to solve for x and substitute x back in. For this problem, we have a first equation. The first equation is 3x plus 2y equals 0. And we have a second equation, which is already solved for y. So notice how step 1 of all of this tells you to solve for one variable, and basically it's already being done for you, right? So it's a good way to notice the hacks here. Problem 3. Look at that. Look at the first equation. What is it already solved for? It's already solved for x. So what you can do here is for equation 1, instead of there being an x here, you can replace this x with what it is, which is 6y minus 7. So go ahead and try these out for homeworks, and good luck. See you all later.